So, hello everyone. My name is Aaryan, and today we are here to discuss Leetcode Weekly contest 429 that took place today in the morning. So, we will be discussing all the four questions. So, let's start with the very first one. So, the first question says that you are given an integer array nums and you need to ensure that the elements in the array are distinct. So, to achieve this, you can perform the following operation any number of times. So, let's write down what we are given in the question. So basically we will be given with an array nums and we have to make all the elements distinct. Cool. And to achieve this thing we can perform some type of operation, and the operation is as that remove three elements from the beginning of the array. If the array has fewer than three elements, remove all remaining elements. So we can remove three elements from start. Cool. Note that an empty array ये तो कुछ नहीं है. So if we check the first example, it is 1 2 3 4 2 3 3 5 7. So 1 2 3 4 2 3 5 and 7. So if we see the first example, we can easily tell that originally the nums array is not having all the numbers as distinct, because this 2 is getting repeated, 3 is getting repeated multiple times, and so on. So in one operation what we can do, we can remove the first three elements. After removing the first three elements, our array will look like this, and we had already performed one operation. Let's erase these two things. Cool. So now even if we look at our array, it is this, but still it has two elements repeated. So what we can do, we can again perform an operation and remove the first three elements. Now our total number of operations are 2, and now we are only left with 3 5 and 7 in our array. Now we can say that all of the elements are distinct or unique. So the total number of operations needed to reach this state is 2. So 2 is the number of operations. So हम ये कैसे करेंगे? If we look at the constraints were pretty low, that the array will have at most 100 size, so we can simulate this process easily. And to remove the elements from the start, what we can do is, the easier way is to reverse the array, because we cannot remove the elements from the start of the array, but we can remove from the back of the array. And if let's suppose we have this array 2 2 2 1. So to remove the first three elements, if this array is reversed, what we can do, we can just remove the three elements from the back, and the process is still remains the same. So we can reverse the array to simulate this process easily. And the another thing that I used is set. My set will store all elements of array, and at any point of time, if my size of set is equal to my size of nums, then I can say all of the elements are unique, because then only the set will contain all the unique elements. Otherwise, if there will be any repeated element, the size of the set will be lesser than the size of the nums. So if we quickly see the code for this, it was pretty straightforward, a brute solution. So what I did was initialized n with the size of nums, which wasn't used anywhere, and operations as 0, and initialize initial set with all the elements, and reverse the original array. Now I run a while loop until this condition is satisfied, that my either my set and nums get equal in size, or the size of the array is totally erased. So what I did was, I popped out three elements to complete one operation, made another set with the new elements of the array and swap both the sets, so that for the next iteration this set will be considered and increase my number of operations and return these operations from the function. And that was the code for problem first. Let's quickly move on to the second problem, which was named as maximum number of distinct elements after operations. तो ये भी यार काफ़ी स्ट्रेट फॉरवर्ड क्वेश्चन था. लेट्स quickly see this. So this is question number 2. So we are given with you are given an integer array nums and an integer k. So we are given with an nums array and another integer k. So you are allowed to perform the following operation on each element of the array at most once. So we can perform some operation on every element only once per element, right? So add an integer in the range to the element. So what we can do, if let's suppose this is element, let's suppose el as the element. So what we can do, we can either add minus k or plus k to our element, and our new element will look like either el minus k to el plus k. So it will lie somewhere in this range, right? So return the maximum possible number of distinct elements in nums after performing the operations. So it was a similar kind of question which I guess was in the daily challenge of Leetcode in this current month, where we can perform the same type of operation and we need to define the total number of same elements that we can get after performing this operation. But in this question it was opposite of it, that the total possible number of distinct elements that we can make. So if we see the first example, 122, or let's say take the second one, 4444 k is equal to 1. So for example 2, it's double four double four and k is 1. So what we can do is we can add minus k or plus k to any of these elements, and the new elements should be uh, in a way that we can get the most number of distinct elements from this array. So let's suppose we make this 4 as 3. Cool. Let's keep this 4 as it is. Let's make this 4 as k plus 1, and let's don't perform any operation on this. So the total number of unique elements that we could get out of it is 3 comma 4 comma 5. So this is 3. So what we did was 3 as our answer. So what we did was we just yeah. So what we just added minus 1 to this, we just added 0 to this, and we added plus 1 to this. And after this there isn't any unique operation for this particular 4. So these were the 4 distinct elements that we could get from this array. So after reading the problem statement and going through the examples, what we could develop the intuition that for any particular given element we can drag it to the range element minus k up till element plus k, right? So to make the most out of this, what we can do is let's make decision for smallest element first. Why? दिमाग में क्वेश्चन आएगा कि यार why should we make the decision for the smallest element first? Because we know that if let's suppose 4434 की जगह if the array would look like this. So if you start with the 4 and you think that let's make this 4 as 3, but there is already a 3 present here. So the best way is to make the decision for the smallest element first and to take it to the most smallest value possible. So what I was saying, key make the decision for the smallest element first, so that we can make the smallest possible value. So if we take the smallest element in our hand and consider the smallest value that it could have, right? So if we just go by an example, so if this is our array, and let's take k is equal to 2 as an example. So there might be a possibility that you start doing performing the operation on this 4. So in that case, what you can do is you can make this 4 from anywhere between 2 to 6. So these are the two options that we can have to make this convert this 4 into any number between 2 and 6, right? But what if I tell you that making this 4 to any number between 2 to 3, 2 or 3 is useless. Why? Because they are already present in this array. So the better way is to take the smallest element first and fix smallest possible value. Cool. अगर हमने ये वैल्यू स्मॉलेस्ट पॉसिबल फिक्स कर ली, सो वी नो टू मेक द डिस्टिंक्ट एलिमेंट्स further in the array, either we are gonna make next value of this. Let's complete this example first. So for this particular example, 1 2 3 comma 4, the smallest possible value with this one, if k is 1, is 1 minus 2, which is basically minus. So minus 1 is the smallest value that we can have. So this is the last value that we can make. Cool. So for this particular 2, what are the values that I can make? It will be 2 minus 2, which is 0, and the max value that I could have is 4. Cool. But what if I had already made this one as 0? In any case, by subtracting 1, then that would be a waste of my operation, because I won't be able to get the distinct element by this. So instead of this, what we did, we made the least possible value with this. And we know, if we want to utilize this to the fullest, what we can do, either make a value which is just consecutive to the last value that you chose, or you can have the least minimal value that you have, because there will be a possibility that this 2 was not present here. So in this case, this 3 can have the minimum value as 3 minus 2 is equal to 1. So for this particular 3, we cannot make 0 as our next value. So in that case, we don't have any option, and we'll have to choose the last value as 1. Otherwise, if there is a possibility that if you have got the scope to make smaller values, so just go with it. Cool. So in this case, let's take minus 1 for particular this one, and for 2 we made the value 0. So let's make this as our last value. Cool. So for this particular 3, the scope was from 3 minus 2 to 3 plus 2, which will be 3 minus 2 as 1, and 3 plus 2 is 5. So our last value is 0. So can we make 1? Yes, we can make 1. So let's make 1 as our last value. So for this particular 4, what is the scope of this 4? For 4, we can either make 2, or we can add this 2 to make it 6. So for if last value is 2, can we make 2? Yes, we can make 2. But there will be a possibility that in some cases this last value that we chose is going out of the scope. How? The first edge case we discovered was, let's take it as 3 comma 5. So if this was the scope of the next element and our last value is 1, we know we cannot make the consecutive value 2. Why? Because 2 is less than 3. But there might be a possibility that the last value is bigger than the max value that I could make. In that case also we are not able to utilize this particular element. So these were the two cases that we need to consider, and always choose the smallest element first and take the least value that it could have, so that we can maximize our values throughout. So if we see the code for this, so majorly my idea was that if all the numbers are plotted on a number line, so for any element, let's consider the most lowest scope of it, and if you are able to make every lowest possible choice, make it so that the largest elements could have more wider scope to choose the number from. So if we see the code, this was the pretty straightforward code for this question. We sorted our vector so that we will process the smallest element first, and initialize n with the size, answer with 0, and last value as some least negative value. So for every current element, my minimum possible choice will be last plus 1, because I had already chose the last value, or my current minus k, because this is the least I can go for any element. So if this value is less than current plus k, so it is within the upper scope, so I can choose it, and this will be my last value. If not, I won't be incrementing my answer, and I won't be changing my last for this particular element. So after performing all the operations, my answer variable will be storing the maximum possible distinct element that I could be able to make from this. So this was the greedy code for this problem, and I hope you understood it. Let's move on to the next problem. So ये काफ़ी अच्छा क्वेश्चन था. It took a lot of wrong answers and penalties to get accepted. So मेरा एक सिंपल फॉर्मूला और एक concept है कि if there are two questions in any contest that are kind of similar or different in just constraints, so always go for the second problem, because if you will be able to get the solution for the second problem, पहली problem automatically solved है. Even if you will not be able to get the solution for the second problem, there might be a possibility that you had already solved the first problem meanwhile. So similarly आज मेरे साथ हुआ था, my second problem got accepted around 840 or 50 850, but at that point of time मेरी रैंक बहुत बेकार थी. But when I got accepted at D, मुझे पता था C already solved है. I submitted the same code and rankings काफ़ी drastically change हो गई थी. So we will be discussing problem D, because C and D were pretty straightforward. The main difference is C has some smaller constraints. So there can be many possible solutions for C, but for D the constraints were pretty high and you cannot just brute it out. So we are gonna discuss the most optimal solution, and you can use the same for problem C. So let's read the problem statement, that you are given a binary string s of length n, an integer num operation. So this is our problem D. So we are given string s, and this is a binary string, so it will only have 0 1 0 1 in it, and it's of n size, and we are also given an variable num operations. Let's see what is the use of this. So you are allowed to perform the following operation at most num of times. तो फिर से operations. So आज के contest में they were all the questions based on these operations thing. So we can perform these number of operations. अब operations क्या थे? Let's see that. So select any index I and flip s of I. So it means कि you can choose any index, and if it's 0 make it 1, if it's 1 you can make it 0. So हम ये कर सकते हैं कि choose any index, choose की spelling गलत है, this will should be this, choose any index and flip the bit. Clear? If it's 1, make it 0. If it's 0, make it 1. So just flip the bit, and you need to minimize the length of the longest substring of s such that all characters in substring are identical. So after performing num operations, operations num operations times, कुछ इस तरीके से ऑर्डर फॉलो करना है सो दैट द लॉन्गेस्ट सबस्ट्रिंग जो भी जनरेट हो विद द सेम आइडेंटिकल एलिमेंट्स वो मिनिमाइज हो जाए. सो लेट्स सी द फर्स्ट एग्जांपल. इट्स 1 2 3 4 5 0 1s. So if we see the first example, it's 1 2 3 4 5 zeros 1, and nums of okay, num operations is 1, so we can perform one operation. So initially longest substring जिसमें सेम एलिमेंट्स हैं वो कौन सी है, दिस वन, एंड इसका साइज कितना है 5. सो हम एक ऑपरेशन कर सकते हैं. लेट्स flip this. So now my new string will look like this. Now the longest substring with same elements कितनी है 2. This is also 2. So 2 is the longest substring with the same elements. So we had already minimized it from 5 to 2. So 2 is the answer that I can achieve. Let's take another example. 0000. All right. So 0000, and I can perform 2 times. So my num operations is 2. ठीक है. So initially the size is 4. Let's say we are gonna change this bit, so it will be 0100. After one operation we can perform another operation because we have two operations allowed. So let's change this one also, so it will be 0101. So now the longest substring with same elements that we can have is 1, because this is 1, this is 1, this is 1, this is, and there is no longer substring with the same elements. So the minimum longest substring with same elements after performing operations is 1 in this case, which is clearly seen here. So this 1010 is pretty much same. There isn't any difference with 0101 and 1010. So this was the question. I hope question clear होगा that what should we do. So the main idea is कि हम इसमें brute नहीं कर सकते हैं. Second thing is, if we see the constraints, it is 10 raised to the power 5. So we either cannot simulate the process, and similarly we cannot choose any DP kind of solution that we for any position try out both the options, that flipping it and not flipping it. So this is not gonna work because the constraints are that n can go up to 10 to the power 5. So in this case this is not gonna work. We have to find some linear kind of solution, or at max n log n kind of solution. Great. So what else we can do to get this answer? So the very first thing that I got into my head is, if there is something like this, so I can get these lengths out कि ये कितनी लेंथ है. If this is 1 2 3 4 5, similarly ये कितनी लेंथ है 1 2 3 4 5, my bad, let's make it 6. Cool, 6. तो अब इसमें से मुझे पहले कौन सी लेंथ को एनकाउंटर करके डीकपल करना चाहिए. ऑब्वियसली इफ़ आई एम अलाउड विद नॉम ऑपरेशंस 1, मुझे पहले किस लेंथ को मिनिमाइज करना चाहिए. ऑब्वियसली दिस, अगर मैं इसको ब्रेक करता भी हूँ दैट वोंट मेक एनी सेंस, बिकॉज इन दिस केस ये ऑलरेडी 6 है, वही आंसर हो जाएगा. सो देयर वोंट बी एनी मच डिफरेंस. सो द वेरी फर्स्ट थिंग इज कि हमें जो मैक्सिमम लेंथ है उसको पहले ब्रेक करना पड़ेगा. इफ़ आई ब्रेक इट आउट एट दिस पॉइंट, by making any of this position change to 1. So now the max length is 3 here, 2 here, and 5 here. So originally it was 6, but now I had made my answer up till 5. What if I am allowed with two operations? Now after seeing this particular string, I can easily say that flipping this bit will be the best possible solution, because it will make it 2, 2, 2, and max 3 similar bits. So by performing two operations, we had cut down our answer from 6 to 3, because the longest substring with same elements is 3 in this case. सो ये तो प्रिटी मच क्लियर है कि जो मैक्सिमम लेंथ है उसी को ब्रेक करना विल बी द बेस्ट आइडिया. सो इनिशियली आई थॉट ऑफ कि लेट्स कलेक्ट ऑल द लेंथ एंड उनके बेसिस पे हम डिसीजन लेंगे यूजिंग अ प्रायोरिटी क्यू, बट दैट डिडंट वर्क आउट एंड उसके बेसिस पे ग्रीडीली कुछ सॉल्यूशंस फेल कर रहे थे. द नेक्स्ट थिंग दैट केम टू माई माइंड that we can, if this particular greedy approach is failing, so the another thing, instead of dp and this greedy, which is left is binary search on answer. That can we binary search on answer? I thought for some time that then the idea clicked that yes, we can binary search on answer. How? We can fix our mid as max length of substring with same elements. Clear? So if my mid is the max length of substring with same elements, what will be my condition check? Because while binary searching on answer, there will be a condition that we need to satisfy. My condition check is, if my max length is fixed, I know if any substring crosses this max length, I need to divide it into two parts, and for this I have to perform some flips. So the total number of flips that I need to get max length as mid, if this flips is less than or equal to number of operations allowed, so I can easily get this answer. So to minimize my answer, I can pull my binary search towards the lower end, and if this is not possible, I can increase my start to get into the bigger third space. So this was the main idea. So if we discuss this thing in detail, so what I thought was कि we are given with a string which is 10001, and let's make it 11111 we are given with a string. Cool. So my search space for my answer will be L is equal to 1 and right is equal to n, because answer will always gonna lie in this space. So based on this, I will calculate my mid and will check, can I make max length, this is not length, max length as mid. अब ये कैसे चेक होगा? सो चेक करने के लिए एक सिंपल सॉल्यूशन है कि आई विल रिस्ट्रिक्ट माई मैक्स लेंथ अप टिल मिड ओनली. हाउ? लेट सपोज my mid comes out to be 2. So in this case, when I will be traversing over this, I encountered a element, then I encountered an element, वो दोनों different है, no issues. If these elements are same, I know my current length up till here are 2, but now I got to know that यार ये length ना 2 नहीं है 3 हो गई, because 3 zeros are there consecutively. So मैं 3 तो allow नहीं कर सकता. What I'll do, I'll put a flip over here. I will change this position to a new element, and I will increase the count of flips that I done till now to 1. Cool. So this is now 1. Now what I'm gonna do is, I know the running numbers are 1, 2, 3, 4, 5, 6. So whenever there are total 6 numbers, so what we initially thought कि जब भी हमें डिवाइड करना होगा, so breaking at the mid position is the best optimal way. Cool. So हम इस पर्टिकुलर लेंथ को मिड के कितने पार्ट्स में हम डिवाइड कर सकते हैं. सो बेसिकली दिस वाज अ लेंथ 2 वी हैड फिक्स. सो इफ दिस इज गोना 1, सो 1 2 3 4 5, 5 वंस ऑलरेडी हैं. तो अब टू मेक इट फॉर एवरी लेंथ 2, मुझे उसको 2 से डिवाइड करना पड़ेगा. सो आई विल गेट कि यार हाँ हमें एटलीस्ट 3 फ्लिप्स परफॉर्म करने पड़ेंगे इधर. सो टू मेक द मैक्स लेंथ एज 2 only. So my total number of flips will increase in this case. So at last, when I will reach at this particular point, whenever my number of flips is greater than operations, so in this case I cannot make my answer using this particular mid value. And if this flips is less than is equal to operations, so this is my one of the possible answer, right? But we have to minimize our answer, right? So if this particular midpoint is one of my answers, I'm gonna search in this particular space, and if this is not, I'm gonna search in a larger space. So this was the main idea behind using binary search. And what will be the time complexity for this? For binary search, it will be log of n, and for condition check, it will be order of n. So the total time complexity came out to be n log n. It will be acceptable. But there was a twist in this question, which was key whenever you are going to submit this particular solution, there will be some wrong answers. And वो क्यों आएंगे? Let's see this thing. So this was the test case on which I got my wrong answer. काफ़ी close था ये, but still this wasn't correct. So the test case was 0 1 1 0. So if we take the example 0 1 1 0, and nums operation allowed are 1. And okay, so I got the output as 1, but the expected output was 2. Why so? So our idea was to check whether we can make an array, oh sorry, the substring having length 1 or not, because we were using binary search. So yes, we can have one. How? अगर हम इसको एक ऑपरेशन को इस वन पे परफॉर्म कर दें, बिकॉज दिस इज इनिशियली विल हैविंग टू लेंथ एज अ सबस्ट्रिंग ऑफ रिपीटेड कैरेक्टर्स. सो हम इस वन को अगर फ्लिप करके ज़ीरो बना दें, सो अकॉर्डिंग टू आवर कंडीशन चेक ये सेटिस्फाई कर जाएगा दैट द टोटल नंबर ऑफ जितने भी थे हमने उनको डिवाइड बाय मेड कर दिया. कूल. बट देयर इज अ इशू दैट ये नेक्स्ट कॉन्जिक्यूटिव एलिमेंट्स के साथ पेयर अप होके अपनी लेंथ को वापस से रिटेन कर लेगा अप टू 2. ये एक इशू है, बिकॉज ये बड़े लेंथ में नहीं होगा. वाई नहीं होगा? बिकॉज इफ देयर इज, लेट्स सपोज, नॉट लाइक दिस, 0 1 1 0. इफ दिस वाज द केस एंड इनिशियली द लेंथ वाज 3, अगर हम इसको 2 लेंथ में ब्रेक भी करते हैं, सो लेट्स सपोज ये हमने चेंज कर दिया, इट विल लुक लाइक दिस. सो अगेन एट मैक्स वो पेयर अप करके भी सिमिलर लेंथ बनाएगा और लेस बनाएगा एंड नॉट मोर देन दैट. बट इन दिस केस वो इंस्टेड ऑफ 1 वो 2 लेंथ के लिए पेयर अप कर सकता है, बिकॉज चेंजिंग अ बिट फ्रॉम 1 to 0 may have some consecutive zeros against it. So that's why ये एक पर्टिकुलर एज केस था और स्पेशल केस था विच वॉज क्रिएटिंग सम मेस. सो इफ यू कैन हैंडल दिस separately, you are good to go. So this was the only issue with this problem. Otherwise, binary searching on answer was the best idea. And to avoid this thing, what we are gonna do, so instead of calculating the total number of consecutive running elements and then dividing it by mid, what we can do, just calculate the alternate flips manually. This was the only possible way, because we are know for every consecutive element they should be opposite of each other. What, how? So basically, if this is 1, it should be 0, it should be 1, it should be 0, then only there will be the maximum length as 1, because if there are two consecutive zeros it will breach this condition. So just check alternating flips manually. If the element is not 0 initially, increase the count of flips, and at last the same condition should be satisfied, that flips should be less than is equal to num operations. So this was the special case in the problem D, and if we can handle this test case, then the question wasn't that tough. So initially, if the size of the string is 0, so we can return 0, because already the size is 0, so there won't be any subarray existing. So this was the start of binary search. Simple finding of mid and checking the condition for mid. So to check the condition, I had made a special case here. If my mid is 1, do this special check for 1 and 0. This 1 and 0 I'll explain later. That this is the number of flips. Run is the running total count of same elements. So if the element is same with the previous element, we are going to increase the running count. If it's not, we can divide it by mid to break into the number of number of subarrays that we are going to make, and this will be the total number of flips that we will be needing at those particular points, and we are going to add it into our count of flips, and we'll reset our run to 1. Similarly, after completing this loop, there will be some value left in the run, so let's accommodate that also. And after this thing is done, so if the number of flips is less than is equal to number of operations, we are good to go. We can return true, and based on that, we are going to search in the lower part, and if not, we are going to search in the larger part. And what is this special check? Special check for size 1. We are gonna check alternating checks. So एक flag हमने यहाँ से set करके भेजा है, which is 1 and 0, because this initial alternating values can start from 1 also and can start from 0 also. So these alternating values can be of two types: 0 1 0 1 so on, and 1 0 1 0 and so on. So they can start from both 0 and 1. So just check for both of them, and this is basically to make this flag to the character type, and if this character is equal, so we need to perform operations here, because we need to change the parity. If not, just switch the flag. So this will switch the flag from 1 to 0 and 0 to 1. So this is just simple thing which will make 1 to 0 and 0 to 1. Cool. So if the number of operations are less than total number of operations allowed, we can return true, and otherwise false. So we are going to check for both the cases. If any of the case returns true, we are going to return true, otherwise return false. So this way we are going to cover the special case also, and if these two things are done, we are good to go, and the simple binary search solution works for both problem D and C. So I hope you understood all of these problems, and thank you so much for your time. And today is 22 December, and there is a div 3 scheduled for today night. So we are also gonna discuss the solutions for all of them. If luckily we will be able to solve them. Otherwise, I will discuss the best problems that I could find in that contest. So thank you so much for your time.